I'm here at TenTenths, one of the world's leading historic motorsport preparation companies, to find out how they overcome some of the problems associated with running such rare and valuable race cars. Modern fuels burn much hotter, and the cars are pushed harder than they ever were before. It will be interesting to see how today's technology helps to keep yesterday's cars on track. Ben, tell me about this 1970s Le Mans Lola.
Well, this is a Lola 297. It started out as a 290 in the late 70s. It's done 5 Le Mans, completed 4, and Nick's owned it since 1978.
And what sort of finishes did it get? What did it achieve?
It came second in 78 and 79, and the third in class in 1980.
So why is heat management so important with a car like this?
With a car like this, with the enclosed bodywork, you get a terrific build-up of heat, and that's very near the fuel system, which is on the left-hand side of the car with the exhaust. And it's important to keep the fuel cool, and also there's a bodywork issue with exhaust being so close.
So can we have a look at that?
Yeah, sure.
I'm really interested to see this because it actually looks like paint.
It does look very much like paint, which is the main advantage, because I've tried to keep these cars looking as historical as possible, and obviously Zircotec coatings weren't available in those days, which is good for us. And obviously the main advantage is keeping the heat in the exhaust as opposed to coming out through it away from the fuel system.
Yes, I can see how close it is to the fuel system,
yeah,
and heat close to that, it could be quite dangerous.
Could be quite dangerous, and also for efficiency of running, the cooler the fuel, the more efficient it is. And also, as you can see, it runs very close to the bodywork.
Now, I've already spotted the bodywork over there. Can we have a look at that as well?
Of course. Yeah.
Brilliant. Is this another Zircotec product?
Yeah, this is Zircoflex.
Okay, it looks like very thin metal, but it's actually a ceramic aluminium hybrid, isn't it?
Yeah, it's 0.7 of a millimetre thick, self-adhesive, and very useful for what we need because of the close proximity of the exhaust to the bodywork, and it reduces the temperature by up to 80%.
We've now moved over to a closed cockpit car, and this Ferrari 250mm is absolutely beautiful, so I'm trying really hard not to get my poppers too close to the bodywork. And actually, under the bonnet here is really beautiful as well. This is another application of Zircotec?
Yeah, absolutely. In this particular instance, it's very highly used for cosmetic reasons and low maintenance, as well as being closed cockpit, is to reduce the heat build-up, which can be quite tremendous on the feet, especially on a similar car we got in racing terms, which is a 250 GTO.
Yes, and I can definitely sympathise there. My first racing car was from the 70s, and it had the engine in the front, gearbox in the back, and the transmission tunnel used to get incredibly hot and heat up the whole cabin, which can be a bit of a distraction. But it's easier to see here, isn't it?
Yeah, absolutely.
I can see there's lots of sensitive electrics around the exhaust manifold here, so that's obviously important to manage heat. How much is the temperature reduced by in terms of percentage, or degrees, if you know that?
Well, with this coating, with the exhaust surface temperature is reduced by up to 30%, and the actual under bonnet temperature is 50 degrees cooler.
Wow, 2 Ferrari Le Mans cars. This one's got an interesting heat story, hasn't it?
Yeah, this 512S was used in the filming of Le Mans with Steve McQueen in the 1970s.
I love that film.
Yeah, it's an all-time great. But sadly, during a special effects scene, it caught fire and burnt out, was then stored, and that's when Nick bought it in that condition, and It's been rebuilt.
And how is Zircotec used in this car?
Well, in this car, being such a vast engine, 5-litre V12, there's a lot of exhaust work under there, and it's again just to reduce under engine bay temperatures.
Of course, heat protection for endurance cars like this is really important because they cover about the same mileage in one 24-hour race as a Formula 1 car does in a whole season.
Yeah, that's true. And again, with this car, with such a large engine and heat build-up under the engine bay, we've shielded the fuel tank, which is just behind the driver, with Zircoflex to reduce the heat transfer.
So we could put it around the chassis.
So this is Terry from Zircotec.
Hello, Rebecca.
Hello. Are you looking at the next application for this product?
Yes, this is Zircoflex, our flexible heat shield, and we're looking at protecting some of the bodywork.
Now, I've seen some amazing cars down here today at TenTenths. Is the use of this product solely limited to historic motorsport?
This product is applicable to all levels of motorsport. In fact, we were on all but one of the F1 cars last season. Lots of the British touring cars, a whole range of motorsport, but not just motorsport. We work with a number of car manufacturers, so Aston Martin use our coating, Lamborghini, Koenigsegg are all our customers. But we'll also work with the car modifier,
Yes.
the general enthusiast.
Wow. So really, anybody who has a passion or interest in cars and performance cars can benefit from this.
Our coatings, our heat shield products can all benefit those applications.
The process involves plasma spraying a ceramic proprietary powder mixture at a temperature of over 10,000 degrees Celsius, which effectively becomes welded to the substrate, resulting in powerful heat protection.